Okay, so the next speaker is present with us today in the flesh. I shouldn't have to introduce him today because he was already here yesterday. But still, let's give a warm welcome to Nguyên Hoang. Just as a reminder, he's a researcher from the PFL in Lausanne and the owner of the YouTube channel Science for All. And now we will be speaking. He will speak about cryptocurrencies and distributed responsibility. Go ahead.
Thank
please.
you. Thank you. Okay, I guess you've all heard of Bitcoin, and I'm guessing that you've all heard as well that Bitcoin is extremely polluting. Here's an estimation from May 2021, like it's evolving every month. So maybe this is already obsolete, but in May 2021, it was above Norway, Bangladesh, or Switzerland in terms of energy consumption. So I have this one thing that's bigger than a country. And well, you can argue that it's not as useful for the welfare of a large number of people as the energy consumed in these countries. So clearly that's a big problem, and the trend is unfortunately still growing. Like there's still more and more energy consumed by these cryptocurrencies. So you might want to ask why. Why is it that we need so much power and so much energy to run this cryptocurrency? And can we get rid of all of this energy consumption while preserving some of the positive aspects of these technologies? Now, to understand this, you have to understand that the thing that's key to these cryptocurrencies, in fact, to not all of them, but to Bitcoin, is an idea called the proof of work. So what is proof of work? So the idea is that these cryptocurrencies are no longer run by a company, by a bank or something like this. Instead, they are run by anyone. They are so-called permissionless, meaning that anyone can contribute to managing all the transactions that are made in Bitcoin. And if you think about this, like permissionless system, it's very dangerous because it means that anyone can enter. In particular, any group that wants to break down a cryptocurrency, or any entity, any company, or any government that wants to disrupt or take advantage of this cryptocurrency can enter the system and be predominant and then hack the cryptocurrency. So this is called a Cbd attack. A Cbd attack is when you're creating a lot of entities or fake accounts, for instance, that are trying to, in order to hack a system. And the idea of Bitcoin, the revolutionary idea back then, is that we're going to reuse something that was done for other applications called proof of work. The idea is that in order to participate to the system, in order to validate a set of transactions made by Bitcoin users, what you are going to need to do is to prove, in a sense, that you have a lot of computational power. So in a sense, like your computational power, the computational power that you're using to participate in the system is going to be a sort of voting right. And if you have a lot of computational power, then you can manage a lot of the cryptocurrency. Of course, for incentive designs, what's going to happen is that you also get credits for this. So what's actually happening is that there's this problem every 10 minutes. There's a new problem on the Bitcoin, and the first computer, the first machine, well, it could be a human, but in practice it's always machines that solve this problem. The first machine that solves this problem gets to write a block of transactions with all of the transactions that it wants to validate. And in this block of transaction, it's also going to say, well, I'm the one who solved the problem, so I give myself that amount of Bitcoin. I don't know exactly, I think it's 12 Bitcoin something today, I'm not sure. But yeah, you give yourself money for having solved this proof of work system. And like remarkably, this has been remarkably effective. If you think about this, Bitcoin is, cryptocurrencies, many cryptocurrencies are the only systems that have been non-interrupted for the last 13 years. Like even Google has breakdowns at some points, like Google is not accessible, but this has always been working. So it's really, really impressive if you think about this. This is very large scale so-called asynchronous system that is still working and never interrupted despite network failures, fires in data centers, and so on. So there are things that are really interesting in this idea, but clearly there's an issue in terms of energy consumption. And it's clear because you're voting with your computational power. So the more computational power you have, the more you earn Bitcoins and the more you also participate in the system. And so from an energy, an environmental point of view, this is of course catastrophic. Now, if you want to know more, I'm just making a bit of an advertisement here. There's a game that has been that has come online called the Blockchain Battle, and I've played it and I found it nice. Okay, so clearly it's all well recognized now in the community that proof of work is not sustainable. Like we have to move beyond proof of work. And the question is, how do we do this? So there are multiple proposals out there. So one of them is called proof of stake. It's used by some cryptocurrencies like Ethereum. And the idea of proof of stake is that instead of trusting computational power, we're going to trust those that have more at stake. Namely, they have more of the cryptocurrency. So if you have more of the cryptocurrency, you have a lot of incentives to make sure that everything is working perfectly, because if there's a breakdown, then your own cryptocurrency will lose value and you're going to lose money. So that's the idea of proof of stake. Essentially, your voting power is how much money you have. So that's good because, on one hand, that's good because, of course, you don't have this energy consumption anymore. But on the other hand, it's like which people will decide. So it feels a bit unfair. And in fact, if you're doing proof of stake, again, you still need to reward those that manage the system. And usually, like if you run very basic models, like the inequalities will grow exponentially. Like rich will get richer exponentially. And well, exponential growth is very big, it's very fast. So proof of stakes has a lot of issues. So again, like it seems like we should try to do better than proof of stake. Now, I'm not going to mention all of the proposals, or many of them, and many of them I don't know. But here are a few that I found. Essentially, well, the proof of space, proof of bandwidth, or proof of elapsed time. One remark to make with all of these proposals is that it all has to do with hardware. Essentially, you prove your identity, that you're not creating a lot of fake accounts by proving that you own hardware. And the assumption underlying is that no one is going to gather too much hardware to control the whole system. But of course, the assumption is not necessarily very reliable. And also, this runs into a race for more hardware, which constructing hardware is very environmentally costly. So again, this is arguing not a good solution. So this leads me to an idea called proof of personhood, which is arguably what we would want, or at least it seems very appealing, let's say. So the idea of proof of personhood would be to go to a democratic system where each person gets exactly one voting right in the management of the cryptocurrency. And essentially, if we manage to have this, to have a proof of personhood, then we could have a cryptocurrency that's essentially using no energy, like a very, very little amount of energy. In fact, in my lab at EPFL, in the distributed computing lab where I work, a lot of my colleagues are working on an alternative cryptocurrency system to do a cryptocurrency called asset transfer. Well, the name is not very important. But the point is that they're doing this very clever thing that doesn't use consensus, and you can instantiate it with proof of personhood, and if you do so, then you have much better performances than Bitcoin and so on. Because one thing I haven't mentioned is that actually Bitcoin is not even practical for the future, because you cannot do that many transactions per second with Bitcoin. I think it's about like 10 transactions max. It's usually a bit less than 10 transactions per second. And in comparison, I think Visa is around thousands of transactions per second. So if you want to really something that scales, you need something better. Also, like for a transaction to be validated on Bitcoin, you need to wait roughly 1 hour. So if you're buying a house, waiting 1 hour, I guess is fine. But if you're buying candies, it may be too much. The point is that if we combine proof of personhood with these other asynchronous algorithms that are designed, then maybe we can get this system that actually scales, that doesn't need an authority, and that is fully verifiable, fully trustworthy, and that can have no interruption over time. That's at least the hope. But one thing that is critical to this, if you want also to make it democratic, is to solve this proof of personhood, to assign to each individual a unique identifier. And to give you an idea of why this is extremely difficult, you have to imagine that people's identities will be stolen, will be lost. If you give someone a card, then at some point, at least one person on Earth will lose this. Another person will get stolen. You can have, of course, identities that are stolen at scale. So this is really a difficult problem. But it's a problem that we already face in democracies, at least. In a democracy, one thing you want to satisfy is the idea that one person has exactly one vote and not more. So every person should be able to vote exactly once. And in order to do this, in democracies, we've made a lot of effort to know the list of people that of citizens in the country, to give electoral cards, voting cards, regularly updated, to recover also the voting rights of people who lost their identity cards, and so on. Now, the issue is that in order to do this today, we need to trust a central authority, like typically a state, a democratic state. And this is not feasible, you have to trust it. And also this is not currently feasible in many countries in the world. So this is really a big challenge if you ever want to have this kind of solution. But I really believe that this is like something we should aim towards. There's not going to be an easy path. Maybe I can talk also a bit about biomarkers like iris image or fingerprints and stuff like this. This also has the issue that it can get stolen. And it can be fabricated as well using deep fakes and stuff like this. So it's arguably not secure enough. So you really need to work this out, and of course it goes beyond computer science. It's a geopolitical question, but the applications are really enormous. Like like I've mentioned cryptocurrency, I've mentioned democratic voting. You could imagine, for instance, for a platform that tries to solve the ethics of algorithms, of recommendation algorithms, like Tonosol, for instance. This would be extremely useful to us, like to make sure that anyone who wants to participate, any human can participate, and that we can make sure that nobody is voting twice. This would be critical, and this would really allow the collaborative design of all sorts of participatory projects. Because if you think about this, any participatory project, any collaborative project on the internet is vulnerable to Cbd attacks, and you want to avoid this. And one last application, which I personally find extremely cool, if we could do this, is the idea of having a universal income. If we can do this, then we can create a cryptocurrency where every month, every person gets a new amount of the cryptocurrency. So that would like automate the design of a universal basic income. Of course, it would have a lot of geopolitical implications that needs to be thought through. But yeah, I just wanted to stress the opportunities that would offer a solution to the proof of work. And with this, I thank you for your attention.
Thank you so much. Thank you. No. Nice. Okay, perfect. Lei, if I'm not mistaken, you won't be taking part in the interactive debates this afternoon. So, if possible for you, we can take a few questions
Sure.
now. And so, does somebody from the audience have a question right now? Yes, over there.
Thanks for the interesting talk. I think you didn't go too much into detail about how proof of personhood actually works. Could you maybe quickly explain how you would establish this one unique ID per person and how maybe privacy of this can be guaranteed so that you unlock the actual national identity with from the unique ID that you assigned in the system?
Yeah, that's an excellent question, excellent remark. So the reason why I didn't go too much into details of how to implement proof of personhood is that I don't know how to implement proof of personhood. But there are proposals out there. So one idea would be like just the way you renew your papers, like every year or every 2 years, you would have these centers where you would have to go in person and prove your personhood in a sense, relate this with previous information and stuff like this. It's very hard, and it's even harder to do this anonymously. Again, there are proposals where you have to meet at a specific space, at a specific time, a bunch of people, and everyone is sort of like vouching for the fact that there is another person, and this way you have a set of codes that are given to the different participants and stuff like this. So that would be one way to go. That could be somewhat privacy preserving and somewhat secure. But of course, it really demands a lot of, like it's costly. Like you need to organize this, and if you want to do this at scale, you need to organize this in different places and to audit the different places. So this is not going to be easy. So that's like kind of like the gold standard, I would say, of proof of personhood. But in the way towards this, which is not going to happen tomorrow, there may be other things that we at least are trying to do on Tournesol. So typically we're trying to validate accounts based on things like email addresses. Like it's not, again, this is far from a very secure proof of personhood, but like given how hard it is, like it's a first step. So typically email domains like louvain.be, you can think of this as a kind of proof of personhood. Like usually the university, I'm guessing, is not giving a lot of emails to a lot of people, so that's somewhat of a slight proof. And the other thing that we're going to set up on Tournesol, and it's also used in other cryptocurrencies, is to have a vouching mechanism, like people vouching that this other person is indeed a person, and that this other person is not using another account. So the first part is easy. The second part is harder. Like you have to know that the other person is not having another account. So yeah, it's not easy, and that's why like it's like kind of like a dream. But there's going to be a lot of work to be done to get close to this.
Okay, so who would like to ask another question?
So yeah, thanks for the talk. So Bitcoin and all the current currencies rely also heavily on the fact that it's a distributed thing, right? Where you don't have to trust the infrastructure of anyone, and they can do their own thing on their stuff, but as long as like a majority is fine, you can trust the system. But once you start to apply this in a universal way, for example, like universal income and things like this, and like on a government scale or global scale, you have two problems, right? One, you start to rely on like nations and stuff, as you just mentioned, for deploying the identities. And second, I don't know, the baker next door won't run their own server, but they will rely on some central server. So do you even then still see a benefit of running this as a cryptocurrency versus as a normal government service?
So yeah, it's a good question, because as you can see in the applications, it's not only about cryptocurrency. So I think there's a lot of motivation coming from cryptocurrency, and that's why the idea emerged in that area. But like I'm more interested in global governance, like in Tournesol, stuff like this. And so I think it should become more and more of a organizational, political question. Try to go with this. And I think like non-governmental organizations, like the United Nations or stuff like this, should get more interested in this kind of things.
So I see proof of personhood has very nice possible applications, but I see there are also possible terrible applications. So even if we had a perfect technological solution to deploy proof of personhood, do you think it would still be worthwhile to deploy it, knowing that there are potential benefits, but also potential risks in terms of mass surveillance, but much worse than today? Possible like enforcing of any kind of constraint, while today it's still possible to have, for instance, anonymity on the internet, and for many services it's still not easy, but possible to be anonymous and not to have too many surveillance. I see that proof of personhood could like provide a simple mechanism to avoid and prevent such possibilities. So I see that as a bit risk, and I feel like there is a kind of balance to discuss ethically before even like starting research on how to do this kind of proofs.
Yeah. So maybe something I should have said as well is you can combine easily proof of personhood with zero knowledge proofs, right? So in a participatory system, you would know that the person that's voting is a person, and that they cannot have another account, but you cannot retrace anything else. Like that's the only thing you know. So like, for those who don't know, like zero knowledge proof is this really cool idea that you can prove only one thing that you want to prove to. So typically, imagine you are arrested because you're drinking alcohol. I guess that sometimes happens in Belgium, and you're underage, and the police officer wants to know how old you are. With proof of personhood, technically would be possible to prove that you are above the legal age, and that's it. Like the police officer would not know more than this. Well, in practice, he would see your face as well. But like if you just give this, you would prove only this, and the other person does not know anymore. And so the idea of a lot of people is to use this really this like really anonymized version, and all you know is that there's one entity that has voted this, or that has that many accounts and that many in a cryptocurrency, and you would escape this mass surveillance issue. I don't know if it was convincing to you. But yeah, definitely it's something to consider.
Hi, thank you for the talk. I was wondering, there already exists kind of proof of personhood, like my ID card, if a police officer comes to me and wants to know my age. So how do you imagine the combination between what already exists and with already security system? I don't know how robust is the current system to prove my personhood, and if there are a lot of fake ID card, Belgian ID card, but how do you combine the already existing system and this proof of personhood that you developed?
Yeah, I think it's definitely an important point, is that in many countries, arguably, we already have a somewhat reliable proof of personhood. It's not always extremely reliable, and there may be some issues. So one of the worst countries, well, it's not one of the worst countries, but a country where it's not ideal is the US. Well, in the US, people are identified with their social security number, which is so easy to hack, so easy to steal, so easy to forge. And well, there are a lot of these that are stolen. And even ID cards, like you have a lot of fake ID cards. At least that's what I see in movies. People, like young people, want to go drinking. They have. It seems like they can find a fake ID card right next to the house. So you have to combat all of this, and I think there needs to be more thoughts into building these systems in a more secure manner, even in states where things are already working relatively well. But yeah, it's definitely an important starting block.
So would you be on board to replace the current system, or would you more likely to be enhancing what already exists?
Yeah, it could be a combination of both. Like I should say, I'm really not an expert in this field, and also like even the experts in this field, like it's quite new. Like people are still trying to figure out. So yeah, like these are very good questions, and I hope some of you will tackle them.
Any other question? We have time for a last one, if someone wants to. Yeah.
Yeah, so a more broad question. So from what you say, I understand that you want to develop this also for countries where it's harder to, where the state is less present, and but these are also countries where like maybe half of the population doesn't even have internet. So, I mean, how do you deal with this?
Yeah, so like having a full-fledged proof of personhood is not for tomorrow. It's like a long-term goal, maybe in 10, 20, 30 years. Well, I guess by then, hopefully there will be more people who will have access to the internet. And it's definitely harder in developing countries or in countries with non-democratic countries in general. Like this is definitely harder. So in order to get there, you need to solve other issues in these countries. So yeah, it's not easy. But again, like maybe using first like the email domains of like you say Louvain or something like this. Then a vouching mechanism where people vouch for one another. Maybe we can build to something that's so my idea is something more probabilistic instead of saying like this is definitely a person, rather than saying well, this is a person with that probability, and to build up from this based on the data we have about them.
Okay, that's it then. Thank you so much. Yep. Thank you so much, Lee.
Thank you.
Thank you so much for your contribution.